if you're new to one of our sessions and don't know about Middleton Group is an Australian-owned and operated specialist engineering consultancy, working in the power, utility, renewable, rail, water, and heavy industrial sectors. Our organisation has been founded with the sole purpose of working collaboratively with our clients to ensure the successful and sustainable delivery of projects. And we are also firm believers in knowledge sharing. So that's the reason we're here today, to share our knowledge. Today's session will be presented by Andrew Russack, who will be presenting on electrical access and permits, safely undertaking HV electrical work. The presentation will run for about 20 to 25 minutes, with about 10 minutes remaining for questions. If you haven't been to one of our sessions before, you'll know, or if you have been, you'll know that if you have any questions, please feel free to use the Zoom's raise your hand feature if it's quite urgent. Feel free to post your questions in the chat, or alternatively, you can just wait till the end and we'll have a thorough question session at the end, which will be facilitated. At the very end of the session as well, I'll post a survey link. If I could just ask everyone to complete that, will just help us bring you more presentations in the future. With that, I will hand over to Andrew. Thanks, Andrew.
Thanks very much, Steve, and good afternoon to everyone. I hope everyone is coping in this lockdown period and getting by, and I hope you've got plenty of work on, but it's not too crazy. So in the next 20 minutes or so, I'm going to take you through my take on electrical access and what it means, how you go about it, and how you do it safely, I suppose. Just a bit of background about myself. I see quite a few familiar names listening in at the moment. It's great to see a few of those names. It'd be lovely to see you in person. But my background, I've had about, well, now 30 years in electricity-related industry, I suppose. 20 odd years in the electricity industry itself, and then about 8 in the rail industry. So perhaps what gives me some experience and the ability to talk about electrical access and permits today is I spent a number of years as the chair of the Field Services Switching Committee in what was ETSA Utilities, that's now SA Power Networks. I had a stint with the Adelaide Metro as its initial, I suppose you'd call me the Chief Electrical Engineer, and helped set up the processes and systems that are now used, probably slightly modified, to operate the system, including electrical access, and spent 4.5 years as Metro Trains Chief Electrical Person, also helping to define electrical access systems, etc. So with that, let's move on. As I said, I'm going to talk today about what is electrical access, why do we need it, some principles. I'm going to focus a fair bit of my time on the switching process and try and give you a framework for the way it works, the way it should work, and then just a very quick summary at the end to sort of pull it together and just recap what we've talked about. So, firstly, what is electrical access? Well, I'd call it, there's lots of definitions, but I'd call it a system of work to make plant normally operating at a dangerous voltage safe, to allow close approach. Now, the reason you want to have electrical access system is you might want to work on the plant. You might need to work at a distance that's not actually on the plant, but it's close or within the minimum safe distances that are either set out in legislation or set out in your operating procedures and principles. Or you might be a non-electrical person and you need access close to that asset, not to work on it, but to be close. And usually the distances for non-electrical, or as it's termed in various procedures and manuals, non-qualified or sometimes non-competent the Blue Book, the Victorian Blue Book, which I'll come to in a minute, which sets out code of practice for electrical, HV electrical work, talks about ordinary person, which makes more sense to me. Someone that doesn't have the training to understand electrical hazards. If you want access, my little picture there's got some tree cutters. They're working close to electrical stuff. They may need the power off to get within approach distances, or the work they're carrying out might mean that branches or their person gets within the close approach distances, or could. So after a risk assessment, it's decided to take the power off. That's the sort of reason. Another thing that's important is to get safe access to the right plant. In electrical isolation, limits of isolation is often referred to, and that's really defining the parts of the electrical assets that you can get to safely whilst a permit is in operation. So moving on, why do we need it? We've touched on it a bit there as far as the sort of work you do, but you've got to manage the risks, of course. Now, it's generally not possible, I'll say permissible is the word I should use here, to work on an unisolated plant, or it's only permissible to work on isolated plant, unless you're using approved live line techniques. Now, the Blue Book, as I mentioned before, which is a code of practice for electrical safety for work on or near HV electrical apparatus for Victoria, makes it clear that you can't do this. Usually every state's got legislation and or codes of practice and or regulations that make this so. Section 9 says an appropriate safe access system should be applied to ensure the safety of work crews for work on near high voltage electrical apparatus or associated with the testing of HV apparatus. I'm going to talk a bit about HV and LV in this discussion, because I think the same principles apply. Unless the risk can be managed appropriately, then the power needs to be off, and that should always be the first approach that's taken. If we remove the electrical hazard altogether, then it's safer for the workers. Of course, if you're in the electricity supply industry or some other industry where the power needs to stay on, you've got to think about the impact of taking the power off. It just goes on and basically says you can't touch it or work on it unless things happen. You've got an electrical access permit in place, and high voltage conductors have been discharged and or earthed at the work site. We'll cover that soon. There's quite a deal of, in that section, there's quite a deal of information about the basics that need to be covered off for a safe permit system. Just continuing on, other reasons we need safe electrical access, as I mentioned, for the non-ordinary person. Apart from that tree cutting example I showed, there might be reasons why people need to get close to electrical assets. Use of cranes, erection of buildings, all sorts of work that could happen close to electrical line. As I said before, work within minimum approach distances of live parts and have safe access to the right plant, which is the correct limits of isolation. All right, let's now set out some reasons why. Let's set out some principles. First thing I want to mention is the safety hierarchy. Now, those that have been around electricity for a long period of time will probably be aware of this hierarchy that's provided. What comes first? Safety of people. What comes next? Safety of plant. In other words, what you do with the system doesn't cause damage to the plant. So whether that be temporary overloading by switching and taking some plant out of service and putting a load onto others, or operating the plant for some other reason above its capacity, you don't blow up your equipment or put it at risk. And the third one is continuity of supply. Now, before I hear a hue and cry from some people attending this webinar, it's certainly a case in some industries and at some time, safety of plant might be put after continuity of supply. certainly in my experience in railways, I don't think I actually had to do this myself or make the call, but sometimes you could allow for a short period of time where plant was overloaded above its recommended maximums to ensure you could keep trains running. The same would apply in industries like mines, perhaps arc furnaces, where you may make a call based on risk and financial impacts that continuity of supply comes before safety of plant. But that's normally the order that things are put in. What's absolutely clear is safety of people is always number one and is head and shoulders above anything else. So when it comes to setting up access systems, that safety of people comes first. The next principle for safe operating is that there's a visible break between the source of high voltage, or any voltage for that matter, and the part of the system or plant that's worked on, and there's a lockout or tag out mechanism, which means that there has to be a deliberate act taken to re-energise the system. It can't happen inadvertently. The other thing that's clear, as I touched on before, is that we only work on isolated earth plant, of course, unless we're using live line principles, and that's a different work system. There is some occasions where plant needs to be unearthed during work. Those things include testing, where you can't obviously test electrical resistance to earth, for example, unless you actually unearth plant. But then a sanction to test or some other permit is required to do that. So there's a safe method of work to undertake that work. If the work involves breaking conductors that are earthed, then both sides of that conductor need to remain earthed. I'll show a diagram later which probably describes that to a degree. The other thing, as I've mentioned before, is our system needs to minimise the plant effect. In other words, when we plan our work, we make sure that we minimise the amount of plant we take out of service. So basically, making a system safe for issue of a permit is all about isolation. And isolation is about switching, basically. So the basic steps for switching for isolation are plan. You plan your switching steps. You do your switching after you've got authority. You apply isolations with lockouts. You prove dead the equipment. You then earth or short circuit, depending on the circumstance or the terms used. Then you issue your permits. So we'll now go through those steps and just discuss how they work. So what have I got here? So I've got a switching diagram. So the start for any planning of switching is going to be a switching diagram. Now this happens to be a low voltage switching diagram, but the same principles apply for any equipment, whether it be HV or low voltage. You've got a switching diagram. It's got switches on it, it's got lines, it's representative of the plant. This happens to be slightly geographical, but it could be just a schematic electrical diagram. So as I said, the first thing to do is develop a program. I'll show you a program of switching in a minute. And basically, a switching program is a pre-arranged series of switching operations that are set out generally on a piece of paper. It's still the case that most switching is done off of paper, but various organisations are trying to move to an electronic system. Certainly easier if you can do that. I'm still someone that doesn't necessarily trust anything that's electronic. It can stop working. I hope my computer doesn't stop working home here at the moment, or the power go off. But usually it's paper-based and allows people to actually mark it up, sign, etc. I'll show you that in a moment. So the switching sheet or program is developed, and then it'll be authorised to be done at a later date. And you always include a diagram, usually marked up as this diagram is, about what's to be commissioned, what's to be switched in the work pack. Very important to have that reference diagram. So here's an example of a diagram. I just want to point out some key a switching sheet, pre-approved switching sheet. You'll see that it's got some identifying numbers. There is dates that the switching is to be carried out. There is the controller. Now the controller here is a recorded line. What that means is that that phone number that could be rung will be recorded. The person that's made the application, their phone number. For emergency contacts, this is how you do it. If someone gets hurt, that's the contact. Then the switching sheet will set out what equipment is to be switched. There's a description here and a location. Limits of isolation in this sheet are a little bit unclear. Probably not the best example I could have dug up, but you can see that it sets out the work to be undertaken. A few important things about it. Switching sheet is a legal record of switching steps, so it's really important that it's filled out correctly. Normally a switching sheet is probably prepared by a competent switching operator and then is either checked by someone else and or approved. Often an independent person that provides the checking might be the network control centre or system control centre. Quite often the switching program is authorised by a control manager or delegate. But the important thing is, from a switching sheet point of view, that it's pre-approved and it's pre-authorised for a time for this work to be carried out. And it's usually a once-off. So we've planned our switching and we've got an authorised switching program in place. What happens next? Well, assuming that the day's come and the switching is about to occur, the first thing we'll do is obtain authorisation for commencing our switching, which probably means calling that number that was on the previous sheet and saying, I'm about to start switching, have I authority to proceed? And that's really important that's obtained, because something could have changed between the time the switching sheet was approved and when the switching commences. Electrical switching is a team event. It's usually carried out by an operator in the field, a checker watching what they're doing and assisting, and usually the system control or network control centre. All three parties have the same switching sheet. Each have different roles to play. The operator obviously carries out the switching. The checker, as per the title, is confirming that switching is undertaken. I won't go into the detail of how that might happen on site, but it's generally very much a very formal approach. It could involve pointing and repeating what the operator is saying and reading off switching sheets, etc. Both of those parties would sign and time each of the operations that occur during the switching event, and they would work closely with the network control or system control person. So once you've got the authority to proceed, as you'll see here, the first step is obtain approval from LV outage coordinator to commence forward switching. Switching usually proceeds, and sometimes switching is permitted a number of steps. The operator might let this, in this case, the operator in the field step out 1, 2, 3. You can see that there's a warning here. Next step item interrupts supply because of their customer service obligations. Can't actually do the next step until such time as probably 8:30 is ticked over or 9 o'clock. Now, another thing I'll mention with switching is that switching, whilst operating switching, undertaking switching, the operator will wear a minimum PPE, and that's normally includes eye protection, non-flammable arc flash resistant clothing, and it's always buttoned up to the wrists, full-length pants, usually a hard hat is normal. Gloves may be optional depending on the sticks or things are used, although these days gloves and switching gloves become pretty much mandatory in anything you're doing, even if they're just riggers gloves, it's usually gloves. For high voltage, usually HV rated gloves are worn. In some cases, insulating mats might be required and other equipment. In a moment while my computer sorts itself out. There we go, right. So I'll just point out on the switching sheet, very interestingly enough, there's a feedback form on the back. If anything goes a bit awry or the switching sheet's not clear or something's not clear during the switching, you can feed it back, which is great. What I would say is that during switching, if there's any errors are found or if there's any doubt with switching stops and the team, that is the operator, the checker and the control person will discuss the way forward. And if there's any doubt about whether the switching can continue, it stops. And that's very important, and it relates back to putting safety of people at number one. Always a team approach though. So we've planned our switching, we've begun our switching, we've undertaken our switching, we've de-energised. What happens next? We lock out. So I'm assuming that most people will be familiar with dangers during operate and lockout equipment. Lockouts can take many forms, but often they're just a padlock. Sometimes they're an individual padlock, and sometimes they're a group padlock, and sometimes the keys for the padlock are then put in a lockbox, etc. But there's different systems. So once you've switched and locked out, you need to prove dead or you've de-energised. So how do you do that? For HV, you usually use a non-contact tester, which is usually sensing electric field. This happens to be a Moddy walk. Any HV operator in Australia is probably familiar with a Moddy walk, and it's a non-contact tester that's often used on a stick like this. And people don't sing out, but that guy's got no hard hat. I'm not sure he's got any appropriate PPE on, but at least he's holding the stick in probably the right way and using a tester the right way. A couple of things to note about using a tester is that the process is always you test the tester works properly, you undertake the test that the conductor's de-energised, then you test the tester. Some testers have a self-test function that can be used, but it's always important. Test, do the test, test the tester again to make sure it's working properly. All right, now the next bit's going to apply pretty much to overhead as far as diagrammatically goes only, although a similar approach applies to cables if work's going to occur on cables. So you've proved dead and you de-energised. What do you do next? You can earth or short circuit. So we've got a floating earth. Let's put some more in here, shall we? So earthing. Here's a basic setup for an earthed section of line. So here's where we want to work. We've got some people actually applying earths. Well, look at this at the moment. Quick comment about earths. You've got your isolation point here locked out. It is most usual to apply a main earth at that point, that potential point of infeed. Another main earth if there's another potential point of infeed. And then close to the work site, as close as possible, there's usually working earths or local earths. Sometimes the main earths are called primary earths, and sometimes the working earths are called secondary earths. There's also other names for them, but I'll stick with those for the moment. The primary purpose of the main earth is to ensure if for some reason this closes or this switch causes energy to be available, there's a very low impedance path for current to flow. And do two things: one, keep the voltage low at that point, and two, make sure the circuit breaker upstream of that device operates. The working earth, its primary reason for being is to ensure that voltages at the location where people are working is maintained close to earth. It also provides a backup for the main earth. Voltages could arise in the working location due to lightning, induction, broken conductors from other lines that cross. Now in the rail industry, quite often you've got other conductors that cross the rail corridor. So you may have a separate earth either side of potential falling conductor. That's normal, particularly on long sections of line. It's very important when you're putting up earth systems or earthing equipment that you keep track of them. Sometimes on the switching sheet, sometimes another way, but it's often said you count the earths out and you count them back in, so you've not left any on the system when you're finished. So that's the basic arrangement for earthing. Now on overhead lines, you'll use equipment like this. Portable or trailing earth, you can see that's a trident arrangement. In fact, there's 4 on there, and a clamp on the bottom that can be applied to a structure. I was very familiar with this sort of arrangement, not with 4 but with 3. This would be a low voltage style earth with 4 conductors. Stove poles make great earth stakes, so you just need a clamp like this towards the top of the pole and you've earthed your conductors. Now, when you're playing with cables, you'll use a thing called a cable spike or a spiking tool, which actually punctures the cable and drives an earthed spike into the cable. So if you're breaking out a cable to work on it, you'll apply this spiking equipment and earth the cable to ensure it's dead before you start work. One thing I will say about applying earths, it's really key that you've proved dead. If you apply earths onto a live conductor, it's not a fun experience. But if it's done properly, it should be safe for the operator. Now you've done all the planning, the switching, the lockout. You now issue permits. Let me go back. But here's just an example of the VESI permit, which is just an example permit for Victoria. The key things are you've got some identifying information. The limits of isolation are detailed here. It says the electrical access permit allows access to, and you've got any conditions in here. And importantly, here's your sign-on area. You've got a recipient in charge. That's the person responsible for the receipt of the permit. They will then make sure others sign on. So the permit gets authorised by the switching person or party, and then it gets cancelled at the end. If there's large work sites or there's a large isolated section, you might find that there's local controllers set up with individual permits. Depends on the organisation and the way they manage the risk. Okay, that's what I'm going to talk about with regards to being in the de-energised state. We can assume now work's been completed. So what do we do next? I'm just going to quickly go through restoration. Here's the steps of restoration. It's pretty much the same in reverse with some key differences. First one, of course, is you must return all permits and make sure they're cancelled. The next step is pretty important. Confirm all works are complete and make sure that you've got assets in a serviceable condition. So there'll be agreed commissioning plans, ITPs or something. Testing will be completed. There'll be a sign-off process for that. That would probably be in addition to the permit process. Lastly, before you do anything, you make sure that all personnel are clear. Now, the permit process will help you with this, but there'll be an agreed process to make sure that all people are clear. It might even be people calling in from remote work sites, etc. Particularly so in the electricity industry when you've got long lines. and people may be operating at the ends of lines to re-energise. That communication is vital. First thing that happens, or the last thing, sorry, that happens before you can do any switching, or the first thing that happens before you do any switching, is contact the authority for a control of switching before restoration begins. So then the next steps are basically the reverse of isolation. Remove bursts and short circuits and ensure they're removed. Remove the lockouts. And then you go through the switching process to energise, and then there'll be a confirmation that all assets are re-energised. Then the system is back to normal, and normal life resumes. Right, now that was only a 20-minute overview. It's the sort of thing you could spend quite a bit of time in the classroom on, and I would have loved to have done an interactive session so questions could be asked on the way through. But basically, we've talked a bit about what electrical access is. We've explained why we need it. Looked at some principles. We have gone through the switching process and how that's proceduralised. And that's it for me. Thanks for listening. If you've got any questions, Steve will probably facilitate them.
Yeah, thanks, Andrew. It was a great session. So if you have any questions for the wider audience, please post them in the chat, or you can come off mute, either or.
Looks like no one's prepared to give me a hard time. This is good.
Any questions, anyone? There we go, Andrew. If you just open up the chat, there's a couple of points in there.
Chat, okay. Just while I'm looking for my chat, can you just read out the first question for me?
Yeah, sure. There was one question. It came from one of the attendees. What should you do if you are not happy with isolation as a worker?
Very good question. Before signing onto a permit, you need to understand exactly what the limits of isolation are and the risks that might be on the work site. So if you're not happy, the first thing to do is stop, obviously. And the second thing is to ask questions of the permit, the recipient in charge, and try and clarify any questions that you have. If you can't, of course, as far as I'm concerned, you've always got the right to say, I'm sorry, I can't work. It's always got to be done sensibly, but it's very important that people have the right to clarify any questions around safety that they have. It's just critical and fundamental to keeping the work site and people safe.
Great. Question from, or a statement from Chris Carter. Can you please outline the process during testing if you have to remove working and operating earth?
Yep, good. Another good question, actually. As I touched on there about sanctions to test. Usually there will be a defined area of the test, limits of the equipment to be tested. Testing usually involves applying a high voltage onto that equipment. So people are kept clear, ropes can be used, other sort of barriers can be used. Obviously the people undertaking the test have the right PPE on, including HV gloves, etc. So there'll be a work procedure that clearly sets out how the test will be undertaken, and there will be a sanction to test provided before the testing starts. People would sign on to that test. That would include removal of earths, they would then put the earths back on at the end of that HV test before the sanctioner test could be released.
Okay. Thanks, Andrew. Another question from Anu. Is discharging part of the earthing step during the switching off process?
Yeah, discharging normally means, in my experience, earthing. Now, there's some equipment that require discharging, particularly capacitors on the system, particularly HV capacitors, and usually they're fitted with some sort of discharge arrangement, or the procedure will require you to wait a certain amount of time when the equipment can be considered safe to earth. So general lines, cables don't generally have a discharge requirement per se. Discharge, probably in the HV manuals, is often used in the context of layman's terms, I would suggest. But particular equipment does have to be discharged, if you like. So a method's usually built in, like with capacitors, to actually discharge them.
Okay. Thanks, Andrew. Question from Mohammed. When do we use the blue book and the green book?
So the blue book's the general code of practice for Victorian electricity operations. The distribution businesses have developed their own book which further defines those principles, and that's the green book. So the electricity authorities in Victoria use the green book, and the blue book is the general one that, say I was to come along and set up I don't know, I've got a warehouse and it's big enough that I've got HV supply with distribution around it, and I've got my own people. They'd follow the practices in that book. I probably have my own procedures anyway, but they would follow that. They wouldn't follow the green book per se. And of course, there's an orange book for traction power in Victoria, just to put all sorts of colours in there.
Great. I think that's all for questions in the chat. Does anyone else have any questions they'd like to come off mute and ask? Okay, there's a question from Anudeep. If multiple padlocks are used and all the keys are stored in a master lock box, who is authorised to hold the key to the master box?
Good question. It probably depends on the procedures that the organisation's got in place. It could be the recipient in charge. It could be the worksite supervisor. I grew up in the electricity industry in South Australia, where generally there was a specific key for each device in, say, in a substation, and there was a general key for switches in the field. So there wasn't necessarily a clear way that the keys were dealt with. It was more an administrative process, which, when you think about it, is sometimes not the right way to do it. But quite as a lockbox, yeah, keys go in that. I would suggest that the worksite supervisor has control of that key, the master key, or it's the recipient in charge takes that key away.
Thanks, Andrew. I've also posted the link to our survey if everyone wouldn't mind filling that out. It's just in the chat. I've also got another question from Grant Smith, Andrew. Is one colour book more stringent than another? I.e., can a green book trained person work on a general HV on consumer side?
So that's a really good question. That's going to have more to do with the licensing point of view. So I don't honestly know how that would work with electrical workers in Victoria. It depends on what the work is, what you're qualified to do. There's discussion about what's on the meter side versus the non-metered side. Generally, in the electricity industry, there's dispensations for people to work without licenses, although most electrical workers these days have licenses. I couldn't say unless there was more context to that question. I think it would depend on the licensing regime in place.
You there, Andrew?
Yeah.
It is Grant. It is Grant. It is me who just asked the last question.
Oh, hello. Yes, hello.
I guess I can elaborate, which is we have people coming onto our site saying they're HV qualified with Green Book training tickets. And I'm suggesting that they're not necessarily applicable to work on consumer HV sites.
I think it would depend on the equipment and procedures that are used. I would suggest they've got the right skill set. Whether they're deemed competent or not would depend on the equipment, the procedures, the systems that were used on site. I would say it's a bit like if you undertake a certificate course under the AQF, you become qualified, but in the context of licensing, you only become competent when you've satisfied the requirements of that licensing authority that you've got the competency. So it's a bit, which one comes first, but you've got to get the qualification before you can get the competency. So it would depend on the systems that were set up on site. I suspect they've got the basic qualifications, then a matter of what regime do you put in place to check that they're competent to do the work, and how that lines up with if it's in Victoria, with the Blue Book.
Correct. That makes sense to me. It's just more of a, how do I say, upper management wanting to tick the right box, saying you've got the right qualified person doing the job. And technically, I don't know how to answer that question. Technically, no, they're a distribution trained person more so than a private lines person.
Yeah, I would suggest that a bridging course would be run. For example, when you undertake certificates under the AQF, normally you've got a base curriculum, and usually that curriculum is interpreted in the context of, an example I know well because I used to help run the training centre. The SA Power Networks Training Centre would take the national curriculum and would interpret it in the context of the SA Power Network. And they would cover the devices and the systems that are used there, but the principles would all be underwritten, if you like, by the AQF. So you just then, if you go to work on a different system, you've got this license that's valid for that equipment. You would then need a bridging course, what's different, to the new system and procedures, new procedure course, new system of operation, to check the boxes. So the person's got the base competency, they just need that bridging course.
Perfect. Thanks, Andrew.
No worries.
There's another question from Brendan in the chat there, Andrew. Would you recommend switching officers wear arc flash PPE to the switchgear arc fault rating when switching of operator earth is in front of switchgear? Or would you be comfortable to switch in standard PPE provided you have provided you have followed steps to prove de-energized, live line LEDs dead, switchgear disconnected or racked out?
Yeah, I reckon this is one of those questions where you go, this is not personal professional advice, because it really depends on the context. I think I get the context has been put. Earthing is generally considered as switching, and all switching should be undertaken with the appropriate PPE, including arc flash, appropriate clothing. Because in actual fact, earthing is probably the most dangerous part of the process if something's not been done correctly up to that time. So even if it's been proven dead, I would still be considering that a minimum level of PPE would be required, including eye protection, the covering that you'd use for normal switching. That would normally be the case. The only way to change that would be having a very stringent risk assessment process. But if I was the operator and I was applying an earth, I'd be having that basic PP on at all times.
Thanks, Andrew. We might just have one last question before we wrap it up. What does the Blue Book say about double isolation for HV work? Is this a nice to have or an additional safety feature?
I honestly don't think the Blue Book talks about double isolation. Generally, in my experience in the electricity industry, a single isolation is sufficient. In the rail industry, where you have effectively complicated overhead systems, where wires cross as they come out of running and get terminated, and also the potential for trains, obviously electrified trains, to run into isolated sections and therefore back energise or energise through the pantograph overhead wiring. Double isolation with a neutral section is quite common, especially in DC systems. It's amazing how many times that train controllers can route trains into sections that they shouldn't be going into under some sort of track access. It's quite amazing. So in general, it's not required in the HV electrical world, but there'd be some situations that it could be possibly necessary, but generally it's not really required in my experience in sort of normal HV and low voltage systems.
There's just one last question here, Andrew, from Suman. What type of HV gloves class needs to be used for HV lines, i.e. 220 kV, while using non-contacting testers or while doing isolation?
That's a good question. Normally on the end of a long stick. So in my experience, it's sort of, I think it's class 3, is it? 22/33 kV style gloves would be used, because you're usually on quite a long insulating stick, 4 metres long, and it's a well insulated stick that you're checking and testing and all that sort of stuff. So it's only a rudimentary level you need of that with that. But again, it will depend on the risk procedures that the business puts in place and the way they deal with it and the way that proving debt is undertaken. So again, I can't provide an absolute answer to that unless you go through that risk process to come to a safe operating procedure, I suppose.
Great. Thanks, Andrew. I think we might leave it there. If you have any more questions, feel free to send us an email or send us a message and we'll be able to get back to you. I've also just posted the link again to our feedback survey. If you could just spend a minute or two just to complete that for us. And with that, I'd like to just conclude by saying stay safe and thanks for joining us today.